Welcome to this video on AutoSys Google Cloud Storage Solution. In this video, we will explain Google Cloud Storage integration with AutoSys and its benefits for the AutoSys user community. We'll provide some technical insights to identify the integration components and understand the deployment sequence. We'll focus on the design and execution sequence of a Google Cloud Storage Create job. Finally, we'll run through a demo. GCS is a service that allows you to store, access, and manage data in the cloud, making it essential for many workflows. With GCS, you can rest assured that your data is secure and easily accessible whenever needed. Its scalable storage options make it easy to adapt, while its reliable performance ensures that your data is always available. Managing data efficiently in GCS is key to successful automation. Integrating AutoSys with Google Cloud Storage allows you to monitor various aspects of storage objects like creation, update of cloud object within your GCS. In addition to that, you can upload, download, copy, move, or check for existence of cloud object directly from AutoSys, enhancing operational efficiency. AutoSys plays a central role in orchestrating operations across multiple environments, including the cloud, and synchronizing these processes with other non-cloud operations. Integrating Google Cloud Storage allows us to centrally configure process automation in AutoSys. Subsequently, we can create, trigger, monitor, and supervise all processes from a single interface. These Google Cloud Storage processes seamlessly sync with different environments supported by AutoSys, such as applications and databases. This integration allows you to execute and monitor Google Cloud Storage jobs through AutoSys. By leveraging AutoSys' advanced capabilities, you can accelerate your digital transformation efforts with greater success. Define your Google Cloud Storage monitoring and CRUD operations and let AutoSys manage the scheduling of these workflows seamlessly. AutoSys lets us build configurations with intuitive interfaces and monitor them through simple dashboard tools specifically designed for operational use. Statuses are indicated, and accessing logs is as simple as clicking a button. From an operations perspective, AutoSys greatly simplifies the configuration and orchestration of Google Cloud Storage. Externalizing operations to a tool with a high degree of third-party integration means we can synchronize all cloud with non-cloud workloads. Using various agents and job object types, we can build sophisticated configurations involving multiple applications, database packages, system processes like backups and data consolidation, file transfers, web services, and other on-premise workloads. The job submission sequence is relatively simple because all job definition properties are stored in the AutoSys plain old Java, or POJO job. AutoSys supports various job types, including create, update, generate, exist, upload, download, delete, copy, or move. For this demo, we will use the create job type. All the target system properties, including the endpoint, token, region, bucket name, and other parameters are defined in the J2E parameters. These parameters may vary depending on the authentication method used. We start with the three main components: the AutoSys scheduler, the system agent, and the Google Cloud Storage server. The AutoSys scheduler submits the POJO job to the system agent. The system agent acknowledges the job from the scheduler and initiates communication with the Google Cloud Storage server. Authentication is then initiated, with the system agent posting token-based authentication depending on the specifications provided in the authentication J2EE properties. In this video, we are using token-based authentication. Once authenticated, the agent submits the job to the Google Cloud Storage server as a post request. The Google Cloud Storage server identifies and executes the matching job. The job execution returns a JSON response that contains the execution details. The Google Cloud Storage server and system agent monitor the job until it reaches its final state. Once the final state is obtained from Google Cloud Storage, The job status in AutoSys is updated accordingly as either canceled, succeeded, or failed. Let's look at how to deploy the integration. First, ensure the Application Services plugin is installed as a prerequisite. The Application Services plugin and Pojo extension have the CFG extension. In older agent versions, you might encounter a PAK file instead. Next, download the plugin extension package from the marketplace. This package contains all the necessary elements. Unzip the package and extract the content into a temporary folder. Navigate to System Agent Install Directory. Next, we must stop the system agent with the cyb agent-s command. Install the plugin extension with the command plugin installer path to CFG file. Now, restart the system agent with the cyb agent-a command. Remember, this integration uses Google Cloud Storage Public REST API. In our demo, we will create a Google Cloud Storage Pojo job in AutoSys. First, let's establishing communication with the Google Cloud Storage server. After communication is established, we can proceed to execute the job. Let's dive into the world of applications and job execution within the Google Cloud Storage environment. Let's start with the demo. In the Google Cloud environment, search for and select Cloud Storage. A list of all available buckets will appear. Select and open any bucket. We have created two folders for this demo, Demo Desk and Demo. Next, let's proceed to log in to AutoSys. Click the Quick View tab to view the job definition. Select the job to open the job definition. The job employs token-based authentication for the demo. When the job is open, click the Quick Edit button to view the required parameter. The first step in executing a job is to select the machine on which the job is to be executed. The first parameter is the class name Google Cloud Storage, and the second is the method name, the create job. Now let's look at the gateway parameters. Understanding these gateway parameters is an essential part of the process. The endpoint parameter indicates where the Google Cloud Storage service resides. The token parameter authenticates with Google Cloud Storage services using either a file or a concise JSON of the file contents. The region parameter indicates the geographical region where Google Cloud Storage jobs will be executed. The bucket name parameter specifies the name of the bucket. The file name parameter specifies the name of the file which we are monitoring to be created on the GCS. The steady state parameter defines how long the file must stay the same before it is marked as successful. The file size parameter specifies the size that a file must reach to be marked as successful. This feature is not currently supported but may be added in future updates. The sleep interval parameter specifies the duration of time the system agent should wait before querying the Google Cloud Storage API again to obtain the job status. The query perm parameter specifies the query parameter for passing additional information or filtering data in a request. The useregex parameter is a Boolean value. Set it to true to enable wildcard regex, matching and false to disable it. The strategy parameter sets the sorting method for file monitoring, which can be chosen from available options or left blank. The log level parameter specifies the level of logging information that should be included in the log file. In the event of a brief downtime experienced by the Google Cloud Storage service, the failure interval parameter comes into play. This parameter specifies the amount of time in seconds before failing the job due to API failure. The return file URI parameter controls whether to return the full URI or the file name. Set to true for the full URI and false for the file name only. Once you have specified all the J2EE and other parameters, click Commit and close it. That completes the job definition. Let's now start the job. Once all the parameters are defined, select Start the job and click Go. To confirm the job's execution, click Yes when prompted. The current run number for the job is 7062. Upon refreshing, a new execution is triggered, increasing the run number from 7062 to 7077. A status of success indicates that the last execution was completed successfully. To access the spool files, simply scroll down on the user interface until you locate the spool files section. From there, select the desired file and click on the Go button. You will then be prompted to specify the number of lines you wish to display. Reports for all statuses are accessible for further investigation or utilization. As we examine the successful job, we can see that all parameters passed by the user, such as job details and authentication parameters, are displayed. Make a note, this is the file name which we are monitoring, and we will use this name for verification in the Google Cloud Storage instance. Now, let's take a quick look at the job status in the Google Cloud Storage instance. Upon refreshing, as you can see, this is the file name which we are monitoring. As file has arrived in GCS, therefore the AutoSys create job, which was monitoring for the creation of the selected file, reached to success state. And that's a wrap for the demo on how AutoSys can integrate with Google Cloud Storage to execute and monitor jobs. Thank you for watching this video.